Greetings. It's interesting to have the regulatory presentation before us because it's very, very important. Things are changing. Change is happening so fast that if you don't embrace the change, you will be wiped out. And one of the changes which is happening in our industry is regulatory compliances. And FERRO, an American company, which is listed in New York Stock Exchange, is continuously working towards fulfilling all these requirements. So I just want to introduce a little bit about FERRO. FERRO Corporation is around 100 years old. We have three verticals. The most important and the growth vertical right now is our color solution business, which comprises pigments, dispersions. And the second one is our ceramic business, where, again, we are coming from colors for ceramics. Now we are getting into digital inks for ceramics. And the third vertical is high technology, surface technologies, satellites, spares for satellites, technology for oxygen sensors, so those kind of applications. In India, I represent the color solutions, and I also manage the Asia Pacific business. I'm going to present what's happening in this industry. Since we have acquired Nubiola, which is I'm coming from, and Capel, I would like to just give a brief introduction about what are the pigments that are available and how we are going to go about before getting into the core presentation of Organoleptic Ultramarine Blue, which is the future for packaging, cosmetics, pharma industry. Okay. We are looking at new horizons. For example, we started with pigments for ceramic, then we moved to ceramic industry raw materials, then we moved to inks. Now we are again coming back to pigments because there is a great potential, and these new regulations are pushing many companies look for new products, and we are constantly engaging ourselves to develop these products to cater to the market. Now, we are becoming a leader. We are a follower in some segments. Now, some segments we are leaders, but we are reinforcing our leadership position by growing organically and also acquiring companies which are doing extremely good products and integrating with our product lines so that we will become single point contact for most of the customers. You can come to us in terms of organic pigments or inorganic pigments or specialized pigments which are needed for specialized applications. So these three represent, right now it's represent FERRO, which is a legacy FERRO corporation, Nubiola, and Capel. Much more has to come. We may increase the numbers. Okay, so larger portfolio. FERRO comes with complex inorganic color pigments, also called mixed metal oxides. Most of you will be knowing pigment brown 24, cobalt blues, infrared reflective pigments, or cool pigments. So we produce these pigments in our FERRO legacy factories. And then we have Nubiola, which comes with ultramarine blues. I was in this previous session, somebody talking about this carbon black, 400 varieties or products. In Nubiola, we have 700 of blue alone, from greenish to reddish to coating ceramic and whatnot. There are 700, but then it's very difficult to manage. So we are now shut down to 300, I think, and we are going to go to 100. And that's our core product in Nubiola range. Also, we have iron oxides, which are micronized, non-micronized, thermal resistant, which can be used in different applications like plastics, paints, ceramics, rubber, and construction. We also have zinc ferrites, which are, again, part of mixed metal oxide range, which can withstand high temperature. Wherever you cannot use yellow iron oxide, you can use this, but there's a difference in the color. Then we have our traditional pigments, which are like chrome oxide green, chrome yellows, molybdenate oranges, anti-corrosives, and basic chromium sulfate. Basically, we are not focusing on that. If the customer wants these products, we promote this product or we sell this product, but our focus is non-toxic and futuristic pigments. And then very recently, we have taken Capel inside. Capel is a Belgium-based company. We gave bismuth vanadate, which is a core product, and high-performance organic pigments like yellow, red, and orange. So this is our company right now. We have broader manufacturing locations. If you look at our locations are from North America to Asia. The color represents the dark blue is ultramarine blue producing units. The light blue could be the mixed metal oxides, and red is organic pigments. We produce in different locations, different products, but we distribute all the products through our sales networks all over the world. For example, in India, we sell products from Mexico, Colombia, China, India, and Spain. So the products are always available at any point of time at our local warehouses, which are located very close to the customer. Why do we have so many manufacturing locations? Because we need to be close to the customers to offer good services. Today, you can have a good product, you can have a good price, but if you are not able to deliver when the customer wants, you are in trouble. And we are learning it, and we are improving it. Hopefully, we will solve it. Okay, so we are a 100-year-old company, but for the past 15 years, we see dramatic changes happening in the market. So we have to be updated, constantly working towards delivering solutions to the customers, be in master batches or compounds or coatings or construction. We need to keep delivering some solution, some part of the solution, so that the customer gets value addition. Otherwise, they don't want to have 7 people delivering the same products. Now, we have listed some of the innovations like encapsulation, which is used in plastics for high temperature. It's used in coating industry, for example, one of the ultramarine blue, which is used in outdoor application, which never used to happen before, but now it's happening. Even automotives are using it. Micronization, which is not new. We have easy dispersion pigments, like ultramarine blue, which is easy dispersible, but even then, there are some at a higher loading is difficult to disperse, whereas we have easy dispersible pigments for even higher loading. There are many. I'm not going to talk all these things because you know already what's happening in the industry, and it's relevant to some products, it's not relevant to some products. But everywhere, we are working on innovation to deliver solutions to the industry, to the customers. And believe me, all these things are coming from you, from the customer requirement. We go to the customer says, okay, we have this issue, can you resolve it? And then we use our expertise, we take internal expertise, external expertise, and try to solve these problems and deliver the product. These innovation centers are located all over the world. We have some in US, some in Germany, some in China. If you look at, there are 3. Again, it's coming from 3 different companies. First one is from FERRO Legacy, and then we have Nubiola range, which is coming from Barcelona. And the third one is Capel, which is coming from Menin, Belgium. Now, this may change in future because we are now integrating all these functions. So instead of having 7, we may have 4, but each one will be specialized in some sort of pigment chemistry. Not on colors, not on inorganic, organic, but some sort of chemistry. So now I'm coming to the core presentation. We are going to talk about ultramarine blue, which is why organoleptic. Organoleptic is nothing but, ultramarine blue without smell, because ultramarine has smell, and it is a problem for many industries. Some are not. But we are now moving towards solving this problem for industries which require no smell. Now, how is it driven? Where is the growth coming from? And what is the technology of NubiPerf? It's nothing but Nubiyola Performance Food Cosmetic Packaging. And conclusions. I will not take much of your time between here to tea, but still. What happens is, before introducing this product, where the requirement is coming from. It's coming from the packaging industry, actually. For example, plastic caps. We took one as one product, and we found out in Europe, how is it moving? There are 240 billion units, which in terms of metric tons, 860,000 metric tons in 2016. In that, non-beverages are 45%, beverages are 55%. Now, when you look at the growth, it may not look big, but for an European standard, it's really big because it's coming from mature industry. 14 to 16 is 1.7% CAGR, and 10 to 14 is 1.5. Beverages are growing at 1%, and non-beverages are growing at 2.2% CAGR. Now, the base itself is high. So these percentages, if we convert it into the metric tons, it's a huge growth. If you look at the same figures in India, the growth could be much higher, but the base could be much lower. Now, what I'm saying is, I'm saying in Europe, it's growing much better than their standards. But in Asia, we need to grow faster because here the basic consumption of plastic itself is so low. That means there is the biggest opportunity exists in Asia Pacific or Asia. And why blue? Because if you look at blue, somehow blue is liked by packaging industry or the consumers themselves. Why? Because it conveys some certain kind of emotions which we have analyzed and found out, which will come in the next slide. When people think or see blue, they look at, some people look at as loyalty, some people look at as peaceful, sobriety, calm, contemplative, and cleanliness. So the blue conveys certain emotions. So companies which are promoting their brands are using this color to convey these messages or reinforce these messages. Now, if you look at the brand logos, top 100 most valuable brand logos, you see the third one, which is blue, okay, which is 35%. The next one is, if in terms of colors, okay, then the red is second, and then remaining other things are other aspects. Now, these are all the brands which exist in Europe, actually, which will be, there are some exist in India, too. So Pepsi is here, PG is here, Unilever is here, Nestle is here, Nivea is here, Fanta is here. So it's maybe 20 years back, some of them were not here, but today everybody is here, and more are coming. Okay, which are all the pigments used for blue coloration? Now we have to go back and see what are the blue pigments used for coloration. Let's see all the brands, and if you see the cap, different colors, nothing is uniform. So that means different kinds of blues are used. And when we look at, or when we analyze these pigments by X-ray diffraction and other methods, we found 91% contains ultramarine blue. That means either it's ultramarine blue, or 15-3 mixed with ultramarine blue, or ultramarine blue mixed with cobalt blue. Somewhere, ultramarine blue is the dominant color in these kind of packagings. So what is ultramarine blue? Now we go back to ultramarine blue. Ultramarine blue is nothing but sodium aluminum sulfosilicate. It's an inorganic pigment. It has oxygen, sodium, sulfur and silica alumina combination. Now, again, why blue? One is the emotions. Emotion alone will not influence. It has to perform, and it has to follow the regulatory compliances, and it has to be cost-effective, and it also provide aesthetic appeal. Now, it may not be only for blue, but for blue, it's much more important because the consumer or the customer sees this. If you look at, I am coming from a cosmetic exhibition now, more and more colors, nail polishes, lipsticks are going into blue. It used to be red. So things are changing. Again, the basic properties like no warping, no shrinkage, high heat fastness, medium heat fastness, let's say this, because 350 is not a high heat, because it used to be high heat for Nuvola, but FERRO it's much higher. Excellent light and weather fastness, ease of dispersion. Most of you know that ultramarine blue is not difficult to disperse. High compatibility with most of the polymers. Ability to tint whites and reduce polymers yellowness. Now we are also finding new applications like for the black pigments, if you add blue, it improves jetness. Of course, the cost of coloration is little higher, but where people need high jetness, they can go for it. Then comes the regulations. Now, BASF friends were talking about EN 71, the toy regulations, food cosmetic, then you have JOSPA from Japan, you have FDA from US. Every 3 or 4 years, these regulations are becoming narrower, stricter. And producers like us have to follow that, otherwise we will be finished. Now, in our case, these ultramarine blues, most of our ultramarine blues, are 99%, follows all these regulations. You know, food contact packaging, standard packaging recoverable through composting and biodegradable, cosmetic and personal care products, and general packaging. Now, there's some more things which I have not put here, is which we were talking about. Internal environmental health safety requirement, which is also to be followed according to the international standards, because we in FERRO take internal pledge not to pollute the environment. Now, we produce pigments without or treating all the effluents, but then there are some blues which are floating in the market, different kind of blues. Some are following these regulations, some are not following these regulations. That is one. So we would like to have all the pigments following this regulation. The second is ultramarine blue inherently has some smell because it's produced using sulfur and it's a part of the chemistry. Now, many times or many years, people thought it's impossible to remove smell from ultramarine blue. And then we were working on it, and then we found a way to remove sulfur completely from ultramarine blue, but not from the gauge, because I will explain how it is coming. Why it is coming is because of regulation. You know, the regulations are keep pushing us, and people are asking that, the factory people are saying smell is coming. People who open the water bottle saying there is some smell. People who open the door of the car say there is some smell. So everywhere there are complaints, or people wanted better products. So it pushed us to have these products coming from our labs. Now, if you see the cage, you have sulfur inside the cage. If you remove that sulfur, it's not blue anymore, it's white. And putting this blue inside is technology. That's why you have very few companies worldwide producing ultramarine blue, and very few produce quality ultramarine blue. Now, which sulfur species are behind any potential organoleptic? Because if you remove sulfur, it becomes white. So you need to have the sulfur, but we need to see which sulfur is creating a problem and how to reduce it and how to demonstrate to the market that it has been reduced. So these are the three challenges in front of us, and we worked on that. Now, before answering, I'll just explain how the blue is produced. It's not a secret. It's China clay, which is kaolin, with soda ash, with sulfur, with some reducing agents, and you get crude blue maybe after 30 days, or maybe after 25 days. It depends, but never below 20 days. Then we mill it, purify it, and get a final ultramarine blue. As simple as that. Now the sulfur path is, it goes from S8 to S2 minus to S minus 3. Now this is the technology which, this sulfur reduction and putting this sulfur inside the cage is the technology. Many people do it. Some people do it better. Now, if you do it properly, this is going to be your ultramarine blue, pure ultramarine blue. No smell, nothing. But it's not that easy. So when you are doing this reaction, there are some sulfur species stay outside. So if you measure your reaction properly and adjust exact sulfur content, you can probably reduce this outside sulfur, but then if do a miscalculation, it becomes white. So there is a very thin line between this and this. So what normally producers do is they always add little more sulfur in their reaction or in the formulation so that there is an insurance that you get blue. But over a period of 100 years, we have a technology so that we don't get so much, we get little, but still we get some sulfur. So if you look at our products which are high performance, still you will get some smell. Then we engage milling process and purification, and this is what I'm talking, One is the formulation, the other one is some process in which we can bring it to this level. This was there until 2015, 14, 15, we can say it. And then one of the car companies, it's not coming from packaging industry, it's coming from the car company, one of the very premium car company. They use ultramarine blue for the interiors. They came back and said, we don't want any smell. And it's all driven by the revenue. So they said, this much is the business we can give you if you can remove this smell. So we have to do this. First challenge is which sulfur is creating this problem. We found out with a lot of experiments. We just first did the normal conventional ultramarine blue. It's giving so many peaks of different kind of sulfur present here. What you see here is the sulfur within the cage doesn't show here because it's not coming out. Then we found out which sulfur to remove, and we found out any sulfur which is outside the cage has to be removed. Not one, not two, not three, everything. And it was 2 years of work in our lab with the different technologies. We finally found a way to remove 100% residual sulfur, which is creating that problem. Now we have this product. The next challenge is we have the product, and we did the analysis, and we found out there is no peaks. Then we said, okay, how do we demonstrate to the market? So we gave the products to the customers, we gave the graphs, and the customers, sometimes, some of the customers were convinced. There are some of the customers, they said, we need a certificate from Switzerland. There is an institute which studies smells. If you look at the studies which have happened there, they have panel of people who test the smell and rate it according to the intensity of the smell. The same ultramarine blue, somebody said it's sulfurous. Some people said it's fruity. So there are various measurements, and then over a period of 6 months, all these panelists check it every day, and then finally they conclude whether it has smell or no smell. And then we got a certificate from this panel of people that there is no smell. And then we went to the another stage. Then we went to another stage. We said, okay, internally, how do we control? And it's little complicated because you have to do stringent tests. So then we said, okay, we normally test sulfur using silver foils. So we intensified this test. It's a test method which is developed by us. And what can be done in 1 hour, we do it in 24 hours. What can be done with 100 degrees, we do it with 150 degrees, because at that temperature, the sulfur sublimates. So we did a lot of experiments, and finally, we have to fix this specifications. Now comes the problem, because we don't have, in this product, there is no sulfur. So how do we fix it, the specifications? Then we said, okay, we cannot say 0. So we said the specification says less than 1 ppm. So once we finalized that specification, panels discussion, and then we started selling this product, then comes the regulations. We said, okay, what are the regulations exist today? What are the regulations may come in future? Because you have to be looking at not this year, next 2 years. So this regulation which is coming here, it will be effective 2019. So we have to make sure that all these parameters are fixed now, not after 2 years. And then we fixed all these parameters and launched this product. So now this product is fulfilling 2019 regulations of EU. Okay, this is the tests which we have done in different methods. Now, before concluding, now ultramarine blue, I said there are 600 and then 300. Now, this is one product. But the customer wants not one product. They said, I need reddish, I need greenish. So what we have done is we use the same technology to produce the most greenish ultramarine blue. And then we produce most reddish ultramarine blue. And then we produce high tinting strength ultramarine blue. So that we put a triangle. You choose what ratio you want to adjust to get your shades. Because if I do it, I will know what is the ratio which you are going to use. So we said, okay, we will give this option to the customer, so that when the customer is producing, only he knows how to get that color. So it's become a proprietary shade of you. So right now, we have 3 shades of this reddish, greenish, high tinting strength. If you want reddish, you can take reddish. You want greenish, you can get greenish. You want high tinting strength, you can take high tinting strength. Or you want somewhere in between in this triangle, it's up to you how do you want to mix it. We can also give you guideline mixings, or you can do it yourself because it's not that difficult. So the conclusion is, ultramarine blue is a pigment of choice for the blue coloration of plastic caps and closures. I'm only talking about caps and closure, but it's universal. There are many, many, many applications. The development of Nubipuff FCP to minimize the potential organoleptic risk associated with the use of ultramarine blue in plastic provides higher insurance to the most organoleptic and safety-sensitive industry players like Danone. Danone is the yogurt, they pack yogurt. This product is used for ice cream packaging in New Zealand. Many, many applications now. There are many, many people are using it. We are bringing it to India. Some of you would have attended some international conferences. You would have heard it a little before. But today we thought this is a nice platform to introduce this pigment. And FERRO pigment specifies and certifies that Nubipuff FCP lot contains less than 1 ppm free sulfur. FERRO pigments, ultramarine blue, including Nubipuff FCP series, comply with all the regulation. You can ask the regulations because we normally have a regulatory department located in Spain, which is centralized, and they are the only ones who give these certificates because otherwise anybody can give self-certification, which we don't do it. It has to come from there. So any certificate you need when you are using these products, we can provide. So I would like to thank my colleagues in R&D and marketing department to produce these slides. And thank you very much. Any questions? Wow, very fast. Short and sweet.
Do we have any questions immediately? Yeah.
Francis again from Plastiblend. You did mention 1 ppm levels. There are other manufacturers who also claim to have organoleptic grades of ultramarine blue, but then they say it's in the region of about 100 ppm. Okay. Now, doing the test is not a simple thing. One needs a panel to evaluate the materials, do the moldings. It's so time consuming. Now, as a manufacturer of a master batch, how do I do that test for an incoming material? Okay, one can do an XRIF, but is there something simpler which I can do by titration?
Yeah, there are very, very simple. There are very, very simple test methods. You can take as 1 centimeter or 2 centimeters silver plate and take the ultramarine blue, put little ultramarine blue, put this plate, put some more ultramarine blue, put it in the oven, 150 degrees, 24 hours, take it out, and you have blank, if you say LAB blank, and then you test it with this, and if it is, delta E is less than 0.1, you know it has very less sulfur. And then over a period of time, if you start testing this, then you will know how intense those sulfur contents are in your pigments. The easiest is you buy a commodity grade and do this and take the LAB value, it's in the range of 100. Then you do it, our Nubi Perf, not 0, but there are others which are having 10 ppm. We will tell you 10 ppm, then you can measure it. So you'll know LAB value for 10 ppm from the blank is how much. And then any incoming, you can just take the thing and LAB, compare it and say it's 100 ppm, 10 ppm, 20 ppm. So you have a data bank. It takes maybe 1 week to do this study, but you can do it. And then maybe you can do it 24 hours. Then you are expertise, you can do it in 2 hours.
Okay.
Yeah.
Thank you.
Thank you very much.